Good afternoon. My name is Anssi Takala. I'm with Outotec and here to talk about sensor-based ore sorting today. So what we're really talking about is removing the rocks that don't contain the desired ore types, and we usually refer to them as waste rock. And because the topic had a word, I think it was economic. So we're talking about wordings related to the economic aspects in this presentation. So benefits is a word which states money, and over here we're talking about increased efficiency and reduced OPEX operational costs. So on greenfield projects, we can talk as well about capital spending and the ability to reduce the capital spending by removing the waste rocks. And this states here that ore sorting may reduce the capital investment in relation to gang removal percentage, and the thing is that the water. You took it away. Thanks. And gang removal is in relation to the removed ore, and in that case we don't mean that it's a direct relation, there's just some kind of a relation. In brownfield projects there's same kind of relation, but really the utilization of ore sorting can increase the existing capacity in relation to the gang removal percentage. So there was quite a few pictures taken during the last presentation. If you want to take pictures, I would say that this would be the one to take a picture of. So this summarizes all the value-added areas of that sorting may produce. One is that it may increase the mineable tons, and when ore sorting is done right after the primary or secondary crushing, it helps to reduce the logistical costs. You can access new raw material streams by reclaiming waste dumps. You can divert ore types, access additional revenues by selling the sorted waste rock as a aggregate. And then there's a lot of benefits in the concentrator plant and after processes, reducing tailings, quantity of tailings, reducing the energy consumption, water consumption, and all this increases the productivity and decreases the unit costs per produced metal ton. So to begin with something, we're talking about particle ore sorting, which is a little bit different thing than bulk sorting. But in particle sorting, all the individual rocks are scanned separately and individually, which doesn't mean that it's slow. It can be quick as well. So to remove waste rocks as early on as possible in the process is a really significant thing, because you can reduce then the crushing cost in downstream process. And the other reality is that this is not a one-size-fits-all solution. It won't work for all ore types. And for example, if there is no waste rock that wouldn't contain metal or other mineral that is our interest, then sorting most likely won't work, because we can't remove something. There's always waste that contains metal. We're losing ore and metal to the waste. So in a way, the term we use quite often in these cases, that we should have clean waste. We don't want to lose too much metal to the waste stream. Fine grained material or finely disseminated material can be a problem for the sorting, and if there's no surface quality difference or a density difference that we can detect with these sensors, then it's difficult to see what is waste and what is product. If there's no association with the marker mineral, for example in gold cases, marker mineral can be pyrite or quartz. If there's no association with the gold to any of the marker minerals, it is very hard to detect and do the pre-concentration with a sorting device. There's other benefits as well, like there's no chemicals needed to this process, and always there must be a screening to get the right sizing for the desired application. And on the ore types that are based on and the separation is based with the sorter to surface quality, it always requires washing. So the basic principles of ore sorting is that material is prepared by screening and possibly washing. Then it's presented to the sensors. Sensors do the detection. The data gets processed in matter of milliseconds, and then there's actually a physical separation event. And in these sorters, it's most typically a pressurized air nozzle that will shoot the rock away. There's two different types of machines. One is which is called the COM series, operates with electromagnetic and X-ray sensors, and in that one the material is presented to the sensor on a conveyor belt. On the Pro series, which are the surface quality measurement and separation method, all the pieces are detected on two sides with the color, near infrared or photometric sensors, and then the separation method happens on a free fall. Here's a summary of the sensor types, and due to the fact that we're now talking mostly about economic benefits, I will pass these by quite fast. The typical applications of sorting are used in industrial minerals, precious stones like gems, ferrous metals, non-ferrous metals, fuels, and then there's slags as well that can be sorted. Just as an example, I'll show you this picture about laser separation and how it works with quartz. Like mentioned before, gold could be associated with the quartz, and on the right side picture, the laser beam is creating a small halo or scattering effect on the quartz piece, and this can be detected, and then all the pieces that contain quartz can be selected to be the product. A little bit different separation method is XRT technology. Basically, it's the same technology that is used on the airports when they scan your luggages. In this case, the picture is processed a little bit more, and dense material particles are shown in the right side picture as blue, and light particle or light minerals as red, and therefore there can be made a separation based on the density. Now, typically, these sorters, especially on the brownfield projects, are placed on a sorter island. In greenfield projects, they can be placed with a fresh layout, a little bit easier in a separate method. But on brownfields as well, it's fairly easy to use the location and just take some of the rock from an old conveyor belt, take it to the screen, and separate it to two different fractions here, and then storage it for a while. Then it's washed in this case, because there's washing screens, and then there's altogether 4 sorters placed over here to do the actual separation. Product goes the other way and waste goes the other way. Now, really the economical effects on mining operations, as said in the earlier, the sorters should be located after the primary or secondary crushers to get the right particle size and minimize all the crushing operations, fines generation, and really to remove the waste rock as early on as possible. Sorters can be placed and utilized on underground mines as well, which is the logistical help. Hoisting capacity can be utilized more efficiently, and waste rock can be left and utilized as backfill underground. The effect on a brownfield typically is as well that because there is now capacity on the concentrator plant or downstream processes that is utilized by mining more, and that really increases the capacity. And when the material that is mined again as the additional capacity will be sorted, then that creates a little bit more waste and more can be mined, and it goes on and on. So there's additional benefits on the sorting. There is potential to grow mineral reserves because the cutoff grade can be lowered. Lower grade feeds can be utilized because only the good rocks that contain the metal can be. Now I ran out. Okay, battery is back. Cost of selective mining can be optimized because sorting is fairly inexpensive, and it can be used to remove the waste rock as well. So if there is a lot of money spent on selective mining, a little bit less selective method can be used, and sorter will do the rest. And metal content in waste is reduced because we're only selecting the good rocks, and this increases the revenue per utilized ton or unit of metal. On the downstream processes, in greenfield project, as said, the capital investment can be decreased, or it can be more bigger plant can be designed with the same cost. In brownfield cases, the additional mining will add the capacity and throughput, and therefore all the per metal unit will be optimized. Crushing and grinding are significant cost factors in mineral processing, so therefore all the waste rock that doesn't need to be grinded down will help significantly the cost equation. And of course there's less tailings per produced metal unit, and this will for example give a longer lifetime to a mine. I have one example over here, and this is a gold solution that is actually a semi-mobile one. The sorters are placed, or sorter is, there's only one sorter, it's placed on a sea container, and this is a gold in pyrites case from Alaska. This sorter was placed in operation in last November, and basically there was a head grade of about 1 gram per ton in this waste pile that was retreated. And the capital investment of this setup was about $1.8 million. And due to the fact that only about 5 to 10%, depending a little bit on the area of the waste pile where it was treated, only about 5 to 10% of the rocks were actually accepted as product. So 90% of the material was still waste. They were able to increase the grade from 1 gram basically to 10 grams or 7 to 10 grams, and investment paid back in about 6 months. Now all the cases are this nice, unfortunately, but this is what can be achieved in selected cases. So that was all that I had for now, and now it would be time to ask any questions if you have some.